Hello students, today I am going to solve top 10 MCQs on atomic structure. First MCQ is in Rutherford's experiment which established the nuclear model of the atom used a beam. Beam of, there are 4 options. We know that the nucleus was postulated as small and dense to account for the scattering of alpha particles from the thin gold foil. Now you know alpha particle actually helium plus 2 ions. In helium plus 2 ions there is no electron. In helium plus 2 ions there is no electron. So actually helium plus 2 ions, or it means it is actually alpha particles. So we can define helium plus 2 by nucleus of helium. Okay, so answer would should be helium nuclei which impinged on a metal foil and got scattered. So option is D. Correct option is D. Now an isotope of 7632 germanium is, there are 4 options. Now what is isotope? Two nucleus is called isotones if they are having same number of neutron. Now in this nucleus the number of neutron is 76 minus 32 means 44. So now you have to count the neutron for each nucleus. Okay, so from in option B it is clear that number of neutron in arsenic nuclei in for this isotope is 44. 77 minus 33 equal to 44. Okay, so option B is the correct one option. The ratio of radii of the first 3 Bohr orbit in hydrogen atom. We know radius of nth orbit according to Bohr's theory is n square h square by 4 pi square mz square. Now so it is clear that Rn varies as n square. Okay, so now R1 is to R2 is to R3. That is the ratio of the radii of the first 3 Bohr orbit. It should be 1 square is to 2 is 2 square is to 3 square. So 1 is to 4 is to 9. So correct option is C. Clear? Now next question is the kinetic energy of an electron in the second Bohr orbit of a hydrogen atom is, there are 4 options. Now you have to calculate the kinetic energy of an electron considering the Bohr's radius. Okay, clear? So we know according to Bohr's postulate we know that mvr equal to nh by 2 pi and v equal to, so nh by 2 pi mr. Is that clear? And we know that kinetic energy of second Bohr orbit, that is why kinetic energy R2. Okay, because we have to calculate the kinetic energy of second Bohr orbit, that is half mv square. Now we know v equal to nh by 2 pi mr, so it will be half m n square e square 4 pi square m square r square. Here r is r2 square because we have to calculate the kinetic energy of second Bohr orbit. Is that clear? Now Rn equal to, we know that Rn varies as n square. Clear? So R1 by R2 should be 1 by 4 means 1 square by 2 square means 1 by 4. Now R2 equal to 4 R1. So according to the question R1 equal to A0, so R2 equal to 4 A0. Is that clear? Now so the kinetic energy becomes half m, so n equal to 2 means 2 square means 4 pi square m Now R2 equal to 4a0. So 4a0 means 4a0 whole square. So half m 4h square 4 pi square times 16 a0 square. So now 4 cancelled out. Now it becomes a square by 2 times 16, so 32 pi square m a0 square. So correct option is C. Clear? Next question is the energy required to dislodge electron from excited isolated hydrogen atom is, there are 4 options. Which one is correct one? So we know energy of nth orbit in electron volt unit, that is minus 13.6 z square n square, as z for hydrogen, that is proton number of hydrogen is 1, so we can write it as minus 13.6 into 1 square means 1, so minus 13.6 by n square. Now we have to calculate the energy required to dislodge electron from excited isolated hydrogen atom. Excited isolated hydrogen means the electron resides in n equal to 2. When electron resides in n equal to 1, then it is ground state. But now, as because in the question it is mentioned that excited isolated hydrogen atom means electron resides in the in the second Bohr orbit. Clear? Now we need to calculate the energy required to dislodge the electron. So dislodge the electron means we have to dislodge the electron to to n equal to infinity, infinity. Okay, means E infinity minus E2. So minus 13.6 infinity square minus of 13.6, here n equal to 2 square, so 1 by infinity means 0, so 0 minus, so it will be plus 13.6 13.6 by 4, so 13.6 by 4 means 3.4 electron volt. So correct option is D. The next question is the radius of first Bohr orbit is x, then de Broglie wavelength of third is nearly. There are 4 options: 2 pi x, 6 pi x, 9x, 2 pi x by 3. Now circumference of a circle is 2 pi r. If r is the radius, here the radius of first Bohr orbit is x, so we can say circumference of a circle is 2 pi x. So circumference is 2 pi x. Is that clear? I think clear. And as according to de Broglie theory, electron can also have wave property. Okay, and waves should be in phase, then this 2 pi x should be equal to n lambda. Okay, now here n equal to 3, because you have to calculate de Broglie wavelength of third Bohr orbit, so lambda becomes 2 pi x by 3. So correct option is D. Now I am showing one picture. From this picture, this 2 pi x equal to n lambda, why I am writing this one, that will be more clear. See this picture. Okay, so in n equal to 3, it is clear that wavelength 1, wavelength, second wavelength, third wavelength. So it is clear that circumference equal to 2 pi x equal to 3 lambda. Next question is The number of radial nodes of 3s and 2p orbitals are respectively, there are 4 options. Now we know that number of radial nodes is equal to n minus l minus 1. Okay, for 2s, n equal to 2, l equal to 0, then 2 minus 0 minus 1, sorry, here it is 3s, sorry, then 3 minus 0 minus 1, so it is 2. For 2p, n equal to 2, l equal to 1 minus 1, so it becomes 0. So correct option is 2, 0. The next question is the orbital angular momentum of 3p is, there are 4 options. Now you need to find out the correct option. We know that orbital angular momentum of any subcell can be expressed as root over l into l plus 1 by h by 2 pi. We know that for 3p, l equal to 1, so 1 into 1 plus 1 by h by 2 pi, so root over 2 root 2 h by 2 pi. So correct option is B. Next problem is that the magnetic moment of mx plus, here z equal to 25, is root over 15 Bohr magneton, and Bohr magneton is the unit of magnetic moment. The number of unpaired electron and the value of x respectively are, that you need to calculate. We know that magnetic moment can be expressed as root over n into n plus 2. Okay, so this one equal to root 15. Now if we square up this equation, both sides of the equation, then it becomes n into n plus 2, 15. Then we need to solve n. Becomes n minus 3 and n plus 5 equal to 0. So n can be 3 or minus 5. So minus 5, it is not it is not possible. So n equal to 3. So here number of unpaired electron is 3. Now electronic configuration of the element having z equal to having number of proton, when number of proton is 25, means at in the neutral state number of electrons would be 25. Then the electronic configuration is argon 4s2 3d5. So obviously when number of unpaired electron is 3, then 2 electrons from 4s and 2 electrons from 3d should be removed. Then the electronic configuration would be 3d3. Clear? Then only you will have only 3 unpaired electron. Clear? So as 2 electron from 4s and 2 electron from 3d are removed, then the oxidation number of M should be plus 4. So x equal to plus 4. Then the correct answer is number of unpaired electron is 3 and the value of x would be 4. So answer is B. Correct option is B. Now which of the following sets of quantum numbers is or are not permitted? We know that for a given number of principal quantum number, the azimuthal quantum number should be 0 to n minus 1 and magnetic quantum number should be minus L to plus L, and spin quantum number can be plus half or minus half, plus half or minus half, right? So here in all case n equal to 3. Clear? So L can have value 0, 1 and 2. Considering this restriction, L can have value 0 to n minus 1 and M can have values minus L to plus L. For 0, L number of L values is only 1, that is 0. For when L equal to 1, the M value can be minus 1, 0, plus 1, and for L value when L equal to 2, then M value can be minus 2, minus 1, 0, plus 1, plus 2, and in each case S can be plus half or minus half. So it is clear that this is not possible. Which one? L equal to 2, sorry, L equal to 1 and M equal to 2. This is not possible. Okay, so this is not possible, so this is incorrect option. Clear? And here n equal to 3 and L equal to 3, this is not possible because L can have value 0 to n minus 1. So here this restriction is not obeyed, so option A is the incorrect option. Actually, so these two sets of quantum numbers are not permitted. Okay, so correct option is A and C. Okay, so today I am ending here, so bye.